This diagram shows at the bottom the hardware, all the components that go together to build this thing called a computer. But the computer itself is incomplete. It's unusable unless we have an operating system that sits on top of it. That's the section in the middle. Starting with the hardware abstraction layer and proceeding upward through the executive services, these are the components of the operating system. Now the section in the blue at the top of this diagram, these are the user's applications. These are the processes and programs that the user desires to run, that actually performs the productive work that the user is trying to accomplish. Next, we're going to talk about applications, processes, and threads. A user double-clicks on an icon. It is linked to some executable, some .exe file that has been compiled. That executable can launch one or many processes. Each of those processes can launch one or many threads. In a Windows or a 32-bit application, this is the way it works. One executable can launch multiple processes. Each process can launch multiple threads. The thread, of course, again, is the small instruction that the CPU can directly act upon. The process consumes resources which are allocated to the process by the CPU itself, through the security system itself. In this diagram we see three processes. Each process has multiple threads, again, thread being the instruction. So again, the thread is an individual instruction, and again it is a subset of a process. The thread again can be directly acted upon by the CPU. Here we see examples of the types of work that individual threads may be performing. Again, thread being a subset of a process being a subset of an application. Processes are in one of three states at all points in time. It's either running, which means it is actually in the CPU and is being executed by the CPU at that point in time. Ready is when the process or the thread is actually waiting for its turn in the CPU, because the CPU can only act on a single thread at any one point in time. At any one instant, a single core CPU can handle a single thread, period. Now the trick here is when the CPU can handle 2 or 3 billion instructions per second, it appears as though it's handling multiple processes and threads simultaneously. In all actuality, it does not. It only handles at any one instant a single thread. So we have running state where the thread is being processed by the CPU. We have the ready state where the thread is waiting for its turn in the CPU. And then finally we have the blocked state where the process is actually waiting for something else, user input, or perhaps it needs data from a preceding process to complete before it can actually have all the information required to move forward and be processed itself. So three states: running, ready, and blocked.